What is Hill cipher? So, Hill cipher is a classical cryptography method. The Hill cipher is a polygraphic substitution cipher based on a linear algebra. It was invented by Lester Hill in 1929, and as you can see, this is Lester Hill. It was the first polygraphic cipher in which it was practically to operate on more than 3 symbols at once. Then, how does it operate? The Hill cipher makes use of a modulo arithmetic matrix multiplication and matrix inverse. Hence, it is more mathematical ciphers than others. The Hill cipher is also a block cipher. So, to encrypt message, each block of n letters is multiplied by an invertible n into n matrix against a modulus 26, and to decrypt the message, each block is multiplied by the inverse of the matrix used to encryption. So, to know more about it, we can see a simple operation how Hill cipher works. So, for a simple operation, we know the formula for encryption, which is C equals to K into P mod 26. Here, K means key, and P is a plain text which will be given to us, and then we have to choose a key for it, which will be must square matrix. So we have taken a key which is 2 3 3 3 6, and a plain text which is attacked. First of all, we have to divide it into groups of two. So for P, we have taken A and T group, and A equals to 0 and T equals to 19, where A equal to 0, B equal to 1, and Z equal to 25 from the table we first saw. Then the encryption method. So we know the formula, which is K into P mod 26. So here the key value and the P value which we have found, and then we do the matrix multiplication. So our matrix multiplication equals to 2 into 0, then 3 into 19, which will be added, then again 3 into 0, 6 into 19. We have to add this also. So the value is 5714, and we will do the mod 26 with it. So after doing the mod, we have found the value 5 and 10, which represent F and K. After that, following the above steps, we will get the C2 and C3 group, which will be M, F, and I, O. Then we can say the encrypted value, which is F, K, M, F, I, 0. Then the decryption to do the decryption, we have to find the multiplicative inverse of determinant, and the determinant will be the key matrix. So the key matrix is 2 3 3 6, and the determinant value is 3, and to do the multiplicative inverse, the K inverse equals to 1 by D adjacent of K. So the K will be K116, K12 minus 3, K21 equals minus 3, and K22 equals 2. We know this from the 12th standard matrix formula, and K inverse equals to 1 by D, D minus 3 minus 3, and it will be transposed, and 1 by D equals, we can say that it is D inverse. To find out the D inverse value, we can use the shortcut method, which is hit and trial method. So in this, we have a formula that is D into D inverse. D's value is 3, and we have to do this mod 26, and the value will be 1. So we need to find the value that makes mod to 1. So if we multiply 8 with 3, their mod 26 value is not equal to 1. But after if we multiply it with 9, the mod value is equals to 1. So the D inverse value is 9. Then so the K inverse value equals to, as we found that K inverse will be the 1 by D and the transposed value multiplied with the transposed value. So 9 into 6 minus 3 minus 2. So as we have a negative value, we have to add positive 26 with it. So it will be a positive value, and then after we calculate it, 225 into 25, 25, and 18. And the formula for decryption is P equals to K inverse into C mod 26, and the C is ciphertext, and K inverse value is what we found from this. Then the decryption value will be C equal. So the description value, as we found that encrypted from C equals to FK IO, we have to make a group with it also. The first group will be FK, and the value is F10 from the table. So P1 equal to K inverse value into 5 into 10. Then after we do matrix multiplication, it will be 260 and 305 against mod 26, and the value is 0, 19. So it is A and T. So after following this step, we can find P2 is TA, P3 is CK. So plain text is attack what we have started from then. Then advantages. So there are several advantages of Hill cipher, and the first of all is the Hill cipher provides a good level of security when used with a sufficient large key matrix. The algorithm is relatively simple, and it can be applied with various types of data, including letters, numbers, and symbols. But it has also some limitations such as vulnerability to known plaintext attacks and the requirement for the key matrix to be invertible. Additionally, it may not be secure as more modern encryption algorithms like AES.